want to give you a little clarification on question 13 in tonight's homework that's in the textbook. You've got this box here, and they give you a picture of the box in problem 13. Let me get this out of the way. The box is 3 kilograms, and it says there are only 2 forces on it. Only 2 forces, and the forces are shown in the picture, and they want you to find the acceleration. So right away, I hope you realize that it's some of the forces. Now, not some of the forces in the x direction. Let me fix that, because it's not going to go in the x direction. Here's the clarification. Imagine you're looking at the box from the top. The box is on a frictionless table, and these, they say, are the only 2 forces. This is not a side view, but a top view. And the only 2 forces are acting on it, so it's probably going to go, not probably, where will it go? It will go sort of in this direction, a little more up than across, right? Because actually, my bad, it's got what you have here is this force acts in this direction, and the angled force acts in 2 directions. So I think I got that wrong. It probably will act a little more to the right than it does up. Now, what really matters is that think about how we added forces on that quiz or early in the year. How do you add these 2 forces? Because I have to find the sum of the forces, which equal m times a. This is what we want to find. We've got this as 3.00 kilograms, 3 significant digits. How do I find the sum of these 2 forces? Well, you know how to do that. How do you do that? You make a table, right? An XY table. The first force is really easy. It only acts in the x direction. Oops. And it has no y component. You remember this? And then we do our trig to get, we take the components of the angled force, the 60 Newton force that acts at 45 degrees. That's what they tell you. It's these 45 degrees. So that I find each component. And now, what do? I add them all up, and I have the x component and the y component of what? Of what we call the resultant, but really what the resultant is the sum of the forces. So I really helped you out a lot on this one. Do you remember how to take the 2 components and turn it into a resultant? Well, these 2 components are, well, an x component. Let's draw a little picture. We've got an x component that goes this way. It looks like it's 82.4. A y component that's this way. It's 42.4. How do you add 2 components, perpendicular components? A squared plus b squared equals c squared. Now, I tell you what. Just give me we want the acceleration. That's sum of the forces equal ma. How about we just, well, it says magnitude and direction. Ooh, okay. To get the magnitudes, we use the Pythagorean theorem. And do you remember the trig function you use to get the angle and direction? So I'll let you, can't do everything for you. So let me summarize. You're looking at a top view. Here are the only 2 forces on the box in the top view. Imagine the box is on a frictionless table because they said these are the only 2 forces on it. So how do I add these 2 forces to find the resultant, or what we've been calling it Fnet, or the sum of the forces? How do we do that? We make an XY table. It's down here. And then we add the x components of the one force. Now the first force, F1, has only an x component of 40 newtons. Look at the picture. It has no y component. Now we have to use trigonometry to get the 2 components of the second force. That's 60 newtons at an angle of 45 degrees. Somewhere they must have told you that. Well, you look at the picture, it says 45 degrees. So what do you do with those 2 components? You add them. Pythagorean theorem to get the magnitude of the resultant, or what is we've been calling sum of the forces. What do you do to get the direction? Tangent to get the direction. Make your little sketch. Looks like it's got, well, this is interesting. No surprise, it's 45 degrees, so it's actually got 2 components that are equal. But what matters is this. Looks like it's got a really big x component. That's what we said in the beginning, 82.4, and a small y component, 42.4. So you do your little sketch. Let me put it over here. Big X, 82.4, and a sketch, a little y, half the y, so it's 42.4. So there is your theta, right? So you can do your tangent. Hope that helps. That is for question, let me see again. Whoops. Question 13 on the homework. So good luck.